Okay, so a pebble is dropped from a cliff 80 meters high. So what this is going to look like is it's going to start at 80 and it's going to go down just like a parabola. Okay, so after t seconds, the pebble is s meters above the ground, where s at t equals this. And again, remember s is going to be like just a distance, so the distance above the ground. Okay, and the domain is 0 to 4. So this would be 0 and this would be 4. So it would drop to the ground at 4, which makes sense because if you plugged 4 in here, it would give you 0. So let's calculate the average velocity of the pebble between the times 1 and 3. So this is going to be our domain for the first velocity. Okay, so s at 1, ways to figure that out is 80 minus 5. So 75. And then let's do s at 3. 80 minus 5 times 3 squared, that's 9. 5 times 9 is 40. So we get 40. Okay, so we have 2 points. We have 1 comma 75 and we have 3 comma 40. So let's find the average velocity. Let's go 40 minus 75, 3 minus 1, negative 35 over 2. Yeah, so negative 17.5. And what is it measured in? Meters per second. Yes, meters per second. Okay, so that would be for A. For B, we're looking at the average velocity between 1 and 1.5. So again, 1, we have the same point, 1 comma 75. But now let's sub in the 1.5. So 80 minus 5, 1.5 squared. So 1.5 squared, 2.25 times 5, we have 11.25. So I'm at 68.75. So that's our second point, 1.5 comma 68.75. We're trying to find the average velocity. We simply do 68.75 minus 75 over 1.5 minus 1. 68.75 minus 75. I get negative 6.25 over 0.5. I get negative 12.5 meters per second. Okay, so why are our answers in A and B different? Okay, so both of them start at 1 comma 75. So let's go here. It's going to be 75. 1 comma 75. Clearly not drawn to scale. That's fine. Okay, so for parabolas, as we go to 1.5, this is not going to be as steep of a slope as when we go to 3. See how the slope right here is going to be different from the slope here? Okay, because as parabolas move further and further away from the vertex, and we know that like 80 comma 0, oh, 0 comma 80, sorry, is the vertex. As parabolas move further and further away from the vertex, they get more and more steep. Now let's talk about instantaneous velocity. So the velocity of an object with the position function st, again, position is going to be the s. You're going to see that time and time again. When t equals a, so we saw this exact thing, but we talked about x equals a. So the velocity, we can call it v at a, equals the limit as delta t approaches 0, so the distance in time, so instantaneous, right? Like we want it to be so close in time that delta s over delta t is going to represent that instantaneous rate of change. So the limit as h approaches 0, and we have the exact same formula, but instead of using f, we're using s, right? S just representing the position function. Okay, so again, note the difference between speed and velocity, okay? Speed is the absolute value of how fast it's going. Something's going, okay? Velocity is both speed and direction, okay? Speed plus direction. So speed is one-dimensional. Velocity is actually two-dimensional. It's speed and direction. Okay, so let's talk about a toy rocket. Toy rocket is launched straight up, okay, wherever it starts, straight up, so that its height, s, in meters, and time in seconds, is given by this equation. What is the velocity of the rocket at t equals 4? So they only give us 1 point. I don't want to do iRocket anymore. Let's actually sub in the t equals 4 to this equation here. Okay, I'm going to show you a little bit of a different approach. I'm going to show you how to sub in, let's go, I'm going to show you how to sub in t equals 4 and then plus h independently and then put it into the equation after. So let's go s at 4, which is just easy, okay, because we know that that's going to be the second part of our equation. So I'm just going to put this in our calculator to save time. -5 times 16 plus 30 times 4 plus 2, I get 42. Okay, and now let's do s at 4 plus h. Okay, -5, 4 plus h squared plus 30, 4 plus h plus 2. So this is an alternative way of doing this. So we have 16 plus 8h plus h squared plus, what's 30 times 4? 120. 120 plus 30h plus 2. You might actually, I know I made 2 mistakes just on negative signs. You might actually be better off doing them separately and then putting them together. So long. Okay, let's put this in order. -5h squared. We got -40h plus 30h, which is -10h. And we have -80 plus 120 plus 2, which is plus 42. That actually looks like a really pretty number, because when we sub it in, they're probably going to cancel. Now, let's actually sub in this 42 and this -5h squared minus 10h plus 42. Let's see if we can do the limit as h approaches 0. We'll go -5h squared minus 10h plus 42. And then we're going to go, and then we're going to subtract the other 42. And that's all going to be over h. Okay, those two 42's cancel out. We're left with -5h squared minus 10h over h. Okay, we can factor that. So those 3 cancel out. We're left with -5h minus 10. Sub in the 0, drop the limit. -5, 0 plus 10. Or sorry, minus 10. There's me in that negative side. So I get the velocity when t equals 4 is -10.